Okay, so the final piece of your curriculum that you need to know for this unit is the idea of division. Okay? Now, division can get even more complicated, and I'm going to present 3 ways to do this. In reality, you actually only need to know 2 ways. One of them, yes, involves the algebra, and you'll see that in a second. Let me just show you that. Here's what it actually says in the curriculum. So what it says, and you saw this before because I had this up when we did multiplication, is that you need to do multiplication and division of polynomials, but you need to model it. That's the idea of the tiles. Okay? It does, however, say that it can be of degree equal to or less than 2. And you may forget what degree means, but it basically means the highest sort of possibility is something that's squared. But I'm actually going to show you something that's a little more complicated today as well, to show you that it's actually not that bad to go beyond that. Okay? And again, multiplication of a polynomial, division of a polynomial. Okay? A strategy for this. Okay? So these are the kinds of things we're going to look at today with this division stuff. Yes, it's complicated algebra, especially for a lot of you, but again, I want to give you that sort of recipe for success. There are 3 ways I'm going to present this to you today. Method 1 I'm going to call long division. So you've heard that term before. Perhaps this is the easiest one to grasp. So it's the one I might recommend the most to you. But it also kind of can sometimes lead to calculation errors. One that leads to less calculation errors is one using what's called prime factors. Now, factoring is actually a big content of the grade 10 pre-cal course. So for those of you who are thinking about pre-cal, you may want to try experimenting with this one. Yes?
Can we turn the lights off?
No, because I've been asked not to turn them off. So we're going to try it without today. Okay? And then the third method is algebra tiles, which you knew was coming. Okay? So it's a visual way. To be honest, you guys should pick the strategy that works best for you. Okay? Now really, it's between these first 2. As I present both of them to you, you may kind of focus on one more than the other. And the way you'll learn that is by practicing it. Okay. So here's the standard method of division. To do this, though, we got to think back to our powers unit. That division power law is going to apply here. So you may remember, it's that idea of sort of dividing things using power laws. Okay? This isn't the one that you need to necessarily focus on, but the idea of those power laws. So here's the problem. Negative 10x squared divided by 2x. If we forget the x's are even there, can you solve that? Negative 10 divided by 2. Sure. Negative 10 divided by 2 is negative 5. Now we can focus on the x's. X squared divided by x is x to the 2 minus 1, or just x. Okay? Another way that you could think of that, again, is if you have this, x squared divided by x, okay? What does x squared mean? It means x times x divided by x. Well, now we can just play like a crossout game. This thing cancels this thing. What am I left with? X. Okay? So it's a way you can look at it. But again, you could use your power laws. 2 minus 1 is 1, right? So similarly, if I did this, x to the power of 5 divided by x to the power of 3, the simple way would be 5 minus 3. But if you don't remember that, just write it out in the long way. 5x's being multiplied together divided by 3x's being multiplied together. That's what it means. Then just cross out ones that match up. And I'm left with x times x, or x squared, or 5 minus 3. So there's a couple different ways you can look at it if you forget your power laws. Okay? So far this doesn't seem that hard. Negative 10x squared divided by 2x is going to give you the answer, negative 5x. Okay. Let's make it a little more challenging. So now it gets more difficult because the numerator of this division can be a binomial or a trinomial, essentially a polynomial. So there's going to be multiple terms up top. Not just one term, but multiple terms. So the way you want to look at these problems now is because there's multiple terms up top, separate it like this. Take that denominator and place it under all the terms. Like that. Okay? So the problem's still the same, just imagine the 5x is under each term. Okay? And it creates more than one problem now. So now, what's 15 divided by 5? 3. What's 10 divided by 5? What's x squared divided by x? What's x divided by x? Not 0. 1, actually. But they cancel each other out. So that's another way you can think of it, right? It becomes 1. Okay? So now, you guys gave me the answer, 3x, and this one is just 2, and that's my final answer, 3x plus 2. Okay? But it's easier if you think of that denominator under each term, or a so-called common denominator. I'm sure you've heard that expression before. Okay, so far it doesn't look, hopefully, too bad. Okay? The way it's actually working, and you guys don't need to know this, but this is actually that thing called the distributive property in play again. That's what's actually happening. We're actually distributing the sort of division through the expression. Some of you may not really grasp that, so that's okay. Just let's bypass that. Let's go with a harder one. Okay, this one looks harder. I got 3 terms up top. And you know how to make terms. You can cake this if you don't know how to make terms. And we have one denominator, a monomial on the bottom. The way to think of this is you want that denominator on all terms on the bottom. So now you can start approaching it. You can go, well, 15 divided by 3, 12 divided by 3, 9 divided by 3. And deal with the variables. Y to the 4th divided by y squared. Y to the 5th divided by y squared. Y to the 3 divided by y squared. Also watch your signs. Positive, negative, 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 positive, negative. So you start to work it out that one. This is obviously a much more complicated one. Okay? So for example, just working out the first one. 15 divided by 3, we're going to get down to that answer. Positive divided by negative, negative. 15 divided by 3 is 5. Y to the 4th divided by y squared, y to the power of 2. Before I reveal it, can anyone guess what this next term is going to become? First of all, what's the sign? Positive, right? Negative divided by negative, positive. What's 12 divided by 3? 4. What's y to the 5th divided by y squared? Y cubed. You guys have got this. Okay? You will work it out, and you got the right answer there. What about this one? What's
negative 3y. Yeah, negative 3y.
Negative 3y. Let's see if he's right. Yep. Put all 3 of these terms together. We get that. Or you can rearrange it to 4y minus 5y squared minus 3y. These are both right answers, just rearranged. Okay? Not too bad, I hope. Let's try another one. Now, bigger numbers, yes. Bigger powers, like 5s and 4s and 3s.
We only have to do it up to 2. No.
That's right, you only have to do up to 2. But could you do this?
Yes.
Let's just work it out together. Okay? So once again, I place this on the bottom of all 3 terms. I start working it out. Okay? And here's what I'm going to get. I'm going to get 4a squared b 0. What is b 0? What's anything to the power of 0? 1, which means it's essentially gone. This one gives me 5a to the 1, or just a, b to the 1, and 6a squared b to the 0, which again means it's gone. Okay? And now I rewrite that. Looks a lot simpler. And with this one, I can actually combine 2 terms. Look, here I have an a squared, and here I have an a squared. What's 6a squared and 4a squared come together? 10a squared. And that's our final answer. Now here's again the idea that this big complicated thing has become this. Much simpler by performing that addition. Now this is a harder question than you can expect on your unit test, and yet a lot of you seem to grasp it okay. Okay? Here's the steps again. Write out the terms, perform the division, watch your exponent laws, simplify, and you're done. You got your solution. So this is the process known as long division. I think it's probably the best one for a lot of you to adopt. But let's try one now called using prime factors. Now for this one, you need to know what factors are. Hopefully you guys know, like for example, a factor of 10 is 2. 2 times 5 gives you 10. So both 2 is a factor of 10, 5 is a factor of 10. Can anyone list another factor of 10?
20?
No, not 20. 10, yeah, 10 is a factor of 10. And 1, yeah. Okay. Now, what's a prime number? Anyone know? You've heard of it before. What's a prime number, Simon?
This might not be right, probably isn't, but it's like you can't times something by itself to get that.
You're in the right ballpark. A prime number is a number that can only be divided by itself and 1. So for example, 3 is a prime number. Nothing can divide evenly. Is 10 a prime number?
No, any
No.
even number can't be a prime number because of 2. Any even number.
Correct. Is 11 a prime number? Yes. Okay? So understanding those two words, you can factor this into prime numbers. Okay, again, this might be a bit tricky for some of you. Shh. Watch as I work this one out. By the way, this is the same problem we did the other way. So let's work it out this way. Okay, here we go. 15x squared is really 3 times 5 times x times x. To get 15, you multiply 3 times 5. Both 3 and 5 are prime numbers. To get x squared, you just multiply x by x. Okay? 10x is derived by multiplying the prime number 2 by the prime number 5, and then an x. So far, everything you see up here is either a variable or a prime number. 5x, well, 5 is a prime number all by itself, and x is there. So what I now have is all these things have been turned into what's called prime factors. Now I just write it out in its long form. So I write 3 times 5 times x, 2 times 5 times x, and on the denominator, 5 times x, 5 times x. And now you just play the cross-out game. That crosses out with that, and that crosses out with that. And what am I left with? 3x plus 2. That's your answer. So this idea of prime factors can actually solve this as well. Now again, I don't recommend this for everyone. This is, you have to understand what prime numbers are. You got to understand what factoring is. That will probably elude some of you, and that's why I might suggest the first method I showed. But let's just try another one of these. Okay, so here I got 3 variables. 5xyz plus 10xy divided by 5xy. Okay, let's start dissecting this. 5xy is really the prime number 5 times x times y times z. 10xy, before I put it up, what would that be? What is the prime factors of 10? 2 and 5. And what about the variables? X and y. You guys got it. 2 times 5 times x times y. What are the prime factors of 5xy?
5.
Yeah, it's a prime number already. So now I'm just going to rewrite this, but in its expanded form. Here it is. And now I just play the cross-out game. 5 crosses out, x crosses out, y crosses out, this crosses out, this crosses out. What am I left with? Z plus 2. I'm done. Okay? So this idea of prime factors can be a solution method as well. One more. Looks like a complicated one. Let's dive into it. 8 is the prime factor. 2 times 2 times 2. That's how you prime factor 8. And then all 5 x's. 12 is 2 times 2 times 3. Those are all prime numbers. Times x times x times x. 4 is just 2 times 2. And then 2 x's. Now let's write it out. This is going to be big. Ready? Oh, I forgot the 4x. One more. 2 times 2 times x. Okay, here I'm going to write it all out now. It's giant, but there it is. Right? So this thing here is really 8x to the power of 5. This thing is really 12x to the power of 3, and this thing is really 4x squared. And on the bottom, this is 4x, 4x, 4x. Cross out. And I'm left with my answer. 2x to the power of 4, 3x squared, and just an x. The prime factor method is a little bit more complicated, but it often yields the most accurate results.
For that answer, what you can do is also you could minus 1x and just make it 3x for the second set range.
Nope, because that's an x squared, so you can't combine it with x. It's a different term. Yeah.
But you're basically x times x minus x.
Yeah, but multiplication is a little different, so yeah. I know what you're saying. It depends if we knew what x was. Okay. Final method is the algebra tile method. Now, to be honest, I hate this method for division, but here it is. To divide using algebra tiles, you take the denominator and you draw it as one of the dimensions of a square. In other words, either the height or the width. So I would take 2x and draw it, and then I fill in the numerator as the whole square. Okay? So the 2x is here. I fill in the rest, and then I read the other dimension at the bottom. That's x plus 4, and that's my answer. The textbook also explains this, so if you're having trouble grasping this, please read the textbook. It has a much more visual sort of explanation of this. But that's the way you do it with tiles.
One of the algebra tiles, you have things you have to learn.
Yep, it's on your curriculum, okay? Okay, let's do some examples, real quick. Solve using long division, okay? So, a big, complicated piece of algebra. We could simplify this. Remember, that piece is going under each of the 3 terms. So separate it into 3 division problems. So what's negative 20 divided by negative 10? 20 divided by 10? 10. No. 2. Negative divided by negative? Positive, right? Then we can deal with the variables. I'm not going to deal with those. What about this one? 30 divided by 10? 3. What sign? Negative. 40 divided by 10? Positive. Very good. Then you would look at the variables as well. Okay? So I'm just going to show you the solution would be, again, all written out like that. Then you dive in. You're going to get 2x squared, negative 3xy, and watch that last one, okay, as well. That's a positive 4y squared. And we're done. Okay? So the long division method has the least amount of steps. But because there's less steps, it's very possible you might make a mistake along the road. So practice it, is my suggestion. So let's try another example. This time we'll use prime factoring. Okay? Big, complicated one. Lots of powers there in play. We'll factor these out. What's 9 factored? 3 times 3. What's 15 factored? 3 times 5. And 3? It's a prime number already. So we could start laying that all out. Now get ready for this. This is nasty. There it is. And I cross it out, and I get down to that. Okay? That is more complicated than you need to know, but you can see the method is the same. Okay. The last example is the diagram example. Again, what you do is you take the denominator and draw it as one of the sides. So x. And then I fill in the numerator as the rest of the shape. And then I just take this other dimension, which is x minus 3, and that's my answer. Again, please read the textbook. It explains it perhaps a little bit better than what I'm trying to do right now. Plus, I will work through these problems with you guys on the board in the other room starting tomorrow. Wrapping up, this is the summary. This is your notes for today. Okay? This is the way you do it for division. Write every term in the numerator over the denominator. Divide the coefficients and variables. You can either do the power laws or prime factors, whichever method works best for you. and simplify whatever you have left over to get a proper answer. If you're doing it with tiles, the 3 steps are labeled here. We just went over them. Okay? That's what it said in your curriculum. I hope I've covered it. Let's get to work on today's problem. And let me just stop that recording.